Hello everyone, I hope you are doing well and everything is okay at your side. Um, Today I want to cover two different topics because these two topics are very important when it comes to advanced data analysis in future when you come through or you come across these two subjects. Confidence. Today I'm gonna have two separate video, or in basically I'm gonna put each topic in different video to have flexibility of when to look at them. The first video, which is this one, basically I'm going to talk about the confidence interval for the population mean, and I'm going to talk as well in the another separate video about the confidence interval for the regression coefficient. We talked about population mean and sample mean. We talked about regression before, and you understand how we do it on Excel and the meaning of that. You got a lot of exercises and a lot of, quizzes. We talked about it, and they are very important. But we didn't come across the idea of confidence interval. How we came to this idea, let me first cover a little bit of, give you a little bit of background. If I take just this part here, up here, to show you how it works here. In fact, usually, as you know, we have always population, and we always take a sample from population by sampling techniques. There are different sampling techniques. And we have on population level some parameters that we call them statistics on the level of the sample, as you know. As an example, we can look at the mean for the population and the mean for sample. But we always interested in the true value of the population. We call it the true value of the population because you have access to the population all. But since in the sample side, we don't have the whole population, we call this mean, in this case, it's a still mean, but we call it estimation because we don't have the full population. If you remember, we have been calling and labeling the mean by X bar for the sample and the estimation, but estimation of what? Of the true value. How we call it in textbooks of statistics and data analysis, we always use the symbol, the Greek symbol, we call it mu. So whenever you read any book or anyone talking about population and parameters, they will always use mu for the mean for the population. And when it comes to sample, we always use X bar. The same we can apply for the other parameters like standard deviation, variance, as well as for regression coefficients. In standard deviation of the population, we use the symbol sigma, and you probably know about sigma and why sigma is important. And definitely, if we talk about variance, we talk about sigma square. But on the level of or the side of the sample, we call the standard deviation by S. So whenever you see S, it means we are talking about sample. If you see sigma, it means we are talking about population. You remember as well, I showed you in previous sessions how you calculate the regression coefficient and the meaning of regression coefficient. But I have been as well talking about the regression coefficient for the sample. That means we call it by B, like the English letter or whatever the Latin letters. But on the level of population, we call it beta, in fact. Okay, so get used to these terminologies because it's very important. The very big question here, because we're going to focus only on the mean in this session. I'm not going to go to sigma, but I'm going also to talk about coefficient in the second video. So the first video, I'm going to talk about how we can get the mu when it comes, if we have only sample. The first thing is, if we have sample only, we will never know mu because mu is only for population. And as long as we don't have access to the population, then we can't really get the mu at all. What we can get is only the X bar. The second question is, okay, if we know the X bar, can we say anything about population mean? Can we conclude that X bar, can say the X bar equals the mu? We can't. So basically, we cannot really say that mu equals X bar or X bar equals mu because we don't know even mu. We don't know it. But we can really have an idea where the mu could be. Usually mu will be around X bar. So if your sample is being selected in a good way, in a representative way, then you can always claim that, okay, if my sample is strong enough and representing the population, then I can claim the true value of the population will be around the x bar, not exactly equals to x bar, but maybe around. The question is how far from the x bar. Then we come to this interesting equation. We call it the confidence interval for the mean, whereby we take x bar as usual, but as we mentioned, the mu will be around how far. So the region of the mu around x bar defined by three elements here. The first element here is called the standard deviation, which is called S, and another element is the sample size. You can see here n. Also, the third element, we call it the t-value. So three elements here, we need to know them, and usually we know them because S is the sample standard deviation, n is the sample size. All what we need to do is this value of t. This t value here basically depends on how confident we want to be. So if we want to be, of course, we cannot really claim that we need 100%, because 100% confidence, it means we want to calculate the mu, which is, as I told you, you need the whole population. So usually we sometimes, as decision makers, we are humble a little bit in a way that we don't request 100%. We request maybe 99%. Maybe if 99 is too much because we don't have enough sample or time, then maybe we can agree on 95 maybe, or maybe 90%. So those are the three standard confidence interval: 90, 95, or 99. So I'm going to show you how to calculate that. So basically, I'm going to focus in this subject about how to get this equation, and then what's the conclusion can we get from this. And then in the second video, another topic, I'm going to talk about the regression coefficient. These two topics are definitely part of quiz 5, so be careful, quiz 5. So you have to really make sure that you understand the content of the two videos, because quiz 5 will be around that, around these topics. First, let us go ahead and take some ideas of some numbers, because number will show you even much better here. So I'm going to go ahead here to show you. You remember the case sphinx here. We have a data set and bunch of numbers, and you remember x19 was basically the customer satisfaction, and we have the independent variables like that. So x19 was the y variable, if you remember that, and x6 and up to x18 were the independent variable. So now I'm going to only focus on one variable at a time to see how we calculate the confidence interval. So I'm going to take the x19 here, control copy. I'm going to put x19 in a new sheet. I call this new sheet x19 confidence interval. I'm going to put it here, control V, and something will happen here, but I will share with you. So I'm going to call this actually x19. I'm going to call it here overall customer satisfaction. Okay, so let me make it bigger a little bit here. So now we have, for how many people here? We have around 100 people. So we basically, the first thing you can do with this, descriptive analysis, sometimes we need to calculate. Sure, the first step is to calculate the average. So I'm going to calculate the average here, and I call it, as you know, we call it x bar here, and the average is easy. I'm going to call it here equals average. Oh yeah, I'm going to use the function average in Excel, and I know where is my data set here. It's my data sets in column A, starting the second row until 101. So I can easily go ahead and select them, but I'm going to write them immediately, A2 to A101, and then I'm going to get a number here. So this number, you have seen it before, and this is, as you know, we call it the estimation of the population mean. Okay, but also I can calculate the count, because you see here the equation, I need the n, so I need the count. So I know the sample size is 100, but if you don't know it, you can always use the function that we calculate here, is called count, right? So let us go for count here, and count, maybe I can easily get the whole column here, because Excel, I missed the T. Excel basically ignores the non-numerical value. So this is the sample size here. If you want to definitely, if you look at the equation here, we need also to calculate the S, which is the standard deviation. So again, in Excel, there is a function, we call it standdev. You can see Excel is offering me two different ones here, point P for population if we want, but we don't have it. So I'm gonna go ahead and use the S one, which is the sample, right? So I'm gonna select it. Again, I think I can do that here in Excel. Sometimes Excel understands what we need here. So basically this is the function. Again, I'm going to share this Excel sheet with you. So I don't need here to write the equations, you know it. You can access the Excel sheet here later on. I'm going to upload it on LMS. You will have access to it. So the very important thing we didn't discuss before, something called standard error here. If we divide the S by square root of n, this is what we call standard error. It's a very popular measure. It's very important. As you can see the equation here, it tells us, hey, the mu could be around x bar, but the x bar will be defined by two big chunk here, the t value and this ratio. And this ratio we call it standard error. So this red one is standard error. So even I might really make it red here to calculate it here. It's basically I'm gonna take the S divided by square root of n here, and I get a value. So basically this 0.119 is actually the standard error. So you need to calculate it. Then how many standard error we are far from the x bar, the t value will tell us here. However, we have still the issue here by asking ourselves the questions. What is the population size? Yeah, maybe it's 1 million, it's maybe more, I don't know. Let me write any number here. But it doesn't matter because I will use the equation irrespective of the sample of the population size. Sometimes if we don't know the population size, this equation is very, very useful to tell us where the mu then. Okay, so the question is, where's the mu then, right? The true value. We don't know. How we know? We don't know so far. So it's always hidden. It's always hidden and hard to get. Because sometimes we don't have access to all population. If we have customers, 100 customer here, what would be our population? Million, 2 million, I don't know, 500 million, I don't know. So it's very not practical to try to get the population, but the equation will give us all what we need here. Now we come to the concept of confidence interval. So confidence interval can be calculated if we know that what we call it confidence level. So confidence interval is an interval, as it says, but the level, it means how much confidence you can put here. It's in percentage wise. So let us put 99%, 95% as a start, because this is one of the standards. Yeah, I made here a mistake. So let me make it 95 like that. So, and this is basically who puts this value. It's usually this input from us as human being. It's us to select. That means we have to say that I want to be 99%. I want to be 90%. So, but there is always cost by asking for high confidence, right? Because high confidence, it means you need more evidence, you need more data. But one of the standards is called 95. Okay, if I am confident by 100, by 95, so how much error in my decision will be? Because if I'm not 100% confident, then there will be always error. This error, usually we call it probability of error, and it's called alpha. So alpha is basically a term, we use it to calculate the confidence interval. And it's very easy, it's basically 1 minus the confidence level. So I'm gonna go ahead here, write 1 minus the 95%, which in this case is 5%. So if here 99 confidence interval, we will be committed 1% error. If 90%, then we're gonna commit or expect 10% error in our decision. Who wants 10%, right? Sometimes you have no choice. Sometimes you have to work in business to take decision on high margin of error here because there is no time to wait. You have to take decisions immediately. There is no time. You have to make it. So sometimes it's very important aspect to choose which value to choose. So let's go back to our 95%. We can always change it later on. Now we come to this little blue one here. It's called t value. I'm gonna t value here. This value we call it t value. I'm gonna call it, yeah, let me make it colorful here for you. just to, when you come back to it, you can see the color are representing something here. So then I'm gonna get the t-value here. T-value, I'm gonna put it here in blue because I have the circle blue. So let me make it here in this color blue, make it bold. And here there is a function in Excel. You don't need to, yeah, you know, probably you knew that from high school, that this value can get it from tables. You can get it from tables if you know the alpha and the degree of freedom, which is n minus 1. We call it actually, this n minus 1, we call it degree of freedom. Degree of freedom. It's a advanced concept. You don't need to know it today, but usually degree of freedom is n minus 1. So let's go ahead here, go and ask Excel to help us. So there is a function called t dot inverse. I'm going to use the two tail here. And you can see Excel is asking for two arguments here, or two inputs. One is called probability. Basically, Excel tells me, give me the alpha. Okay, this is the alpha. And it asks me about the degree of freedom. Okay, I know that degree of freedom in this case is n minus 1. So, and I know n is equal 100. So I can go ahead, take 100 and subtract 1 from it. Then I close the brackets and then I satisfy this language, and this function, I mean. Then I get the value here. So again, this is what we call it. You can see it's close to 2, right? So if I make it 99, it will be 2.6. 2.6 what? 2.6 standard error. How many standard error you can be far from X bar in order to find the true value of the population? So you need to go 2.6 standard error to the right, you can, and 2.6 standard error to the left. For 95%, you can go plus or minus 2 or something like that. So that's a very useful method here. So, but based on that, I need to translate. This is a value, this is number that has no units. So if your data is in dollars, this is not dollars, that is just a unit. It's unitless, has no unit. Let me write here, has no units. So it's unitless, right? But we need to translate this number into our currency or our language. So the only way to translate it into our currency, or in this case, I mean our unit, if our data is in dollars, then we need to translate in dollars. Then I need to use another function. It's called margin error. Basically, I use the t-value here. I don't know why it's there's a space here. Okay, so the t-value that I calculate here, let me write it complete. And why not to make it here blue? Again, just to make your life easier when you want. And multiply by the red one here. And this is the red one here. Maybe it's easier for you to know that in the equation you can see what I'm talking about here. So basically all what I need to do is to multiply the t-value by the standard error. Then we come to a value, we call it the error margin. Basically now it has the same unit as it has now. It has the same unit as raw data. Okay, so let me make it here visible for you. So it has the same unit now. So here has no unit. Now now it's easy to calculate the lower limit and the upper limit of the whereby this limit or this region, whereby this region will entail the true value of the population. So I'm gonna highlight this both. All what I need to do is to, here I call it the lower limit for the true mean, which is for population, basically equal the X bar, which is this one, minus the error here. So now this is the lower limit. As for the upper limit, I take the average, and now plus this error, this margin error. Now I know it's that although the X bar for the sample is 6.918, and I know also that I cannot equate it to the population mean, but now I have information, new information tells me, hey, although this is the average of your sample, but I can give you an interesting information whereby I can tell you, hey, the mu, which is the true value of your population, can fall in this region, which is very fantastic information, to be honest. And now we can call it like this. We are 95% confident. Why 95? Because we selected 95 here. Confident that the true value of the mean Yeah, this is the mu, falls between now 6.68 and 7.15. So now we can make decision on the population level. It's very important. So it's this is a very important thing. So now you can see if I increase 99 here, what happened here to the region. Now with this equation, you can see it, I wrote it in equation form. You can always look at it later on. We are 99% confident that the true value is between this and this. You have noticed that when I increase 95 from 99, try to look at the width of this interval. This is the width of the interval by multiply by 2, definitely, because you can go to right and left. But if I make it 99, the value increase. So be very careful. When we increase confidence, the error margin will increase, and the region that where we try to find the mu is even bigger, because we want to be more confident. But it's the accuracy is less, right? Because the bigger the wider the region here, it means we are not accurate. So there is always two terms: accuracy and confidence are conflicting to each other. So you can get high confidence, but the price is accuracy. If you want high accuracy, the confidence will be the price. If you want both together, you need to increase the sample size. So this is the cost. Okay, you can play with this Excel sheet later on, and you can know that. But now it doesn't really, we don't stop at this point, because we need to know if, you remember the case that each variable has a benchmark. If our customer happy or not. Now it's 6.91, which is mean 6.92, something like that. But do we know that if our customer happy or not? Then we need to check the benchmark of our data. So if the benchmark of the market is 7.2, the question is how far we are from the 7.2. So this is our actual data, and this is the benchmark. So some of you might really say, let us get to the X bar here to make it easy, because I'm going to scroll up there, and because I need some space. So now we understand that the X bar is basically equal the E1 here. So just to compare, now we can calculate the difference between both of them. It's easy by taking the X bar minus the 7.2. Now I know that I am less, because that's why it's negative. I am less than the benchmark. Some of us will look at this number, say, hey, this is a small number. So it looks like people, yes, they are not happy, but it's not much. Should really do effort to improve our business, or it's not important? We cannot, some people say, no, this is very significant. We need to invest money. So the question became very important in decision making. Should we consider this value significant or insignificant? Because if it's a significant value, then it means that we have to invest to improve our business. But if we see that's not significant, it's really trivial number, we can ignore it, then we're going to save money. But maybe saving money is not a good idea. So anyways, but in the end, it's not really us to decide this big value or not. We need to use some statistical techniques. The statistical techniques that I'm going to use here, it's the same as we discuss here. We make use of what we learned up here to do it here. So basically, instead of calculating the lower limit for the true mean, because I don't know it, using the X bar, the question is, why not to get the lower limit for the benchmark, as well as the upper limit for benchmark, using the same idea. So basically, all what I need to do is to take the benchmark and subtract the value that we got from here, and take the upper limit of the benchmark by adding the value that we got here. So now I have two limits for what? For the benchmark. Let me go back here for 95%, because it will be interesting to see what's going to happen here. Now I can claim that the conclusion that, as you can see here, 6.96 and 7.44. If I make it better formatting here to see a little bit, 2 digits here better, or 2 decimal points, to make it easier for us to read it. So if you can see here the average here, let us make it as well 2 decimal points. 6.92, it's basically it's outside. It's less than the lower limit. If it's lower than the lower limit, then it's outside of our tolerance. So our tolerance is this. As long as our average will be within this, then we are within the benchmark. If we are outside this, we will be outside the benchmark. Maybe if we are less than the lower limit, then means we are worse than the benchmark. But if we are greater than the upper limit, then that means we are better than the benchmark. So we can draw the conclusion by knowing that based on this value, 6.92 is definitely less than the tolerated lower limit, then we are definitely worse than the market. But be careful here. If we change the 99%, make it 99, look what happened here. It's basically, it tells us, hey, the lower limit became 6.89, which actually managed to include our average inside, which means we are not significantly far from the benchmark. So basically, I can read it for you here by saying we are okay. There is no significant difference from the market because our average here is basically, let me make it a different color here. I hope it will be visible for you. Our 6.92 is 6.92 as an average is inside this region. So this is the lower limit and this is the upper limit. So it looks like we are okay at 99. But when we go back to 95 or less, to be honest, then you can see here 6.92 became less outside this. So we are worse than the market. If you want to check this equation, you can check later on. Let me summarize and then I close this video for you to see, and then we talk about another topic in another video. So I'm gonna highlight this here and make it visible for you to see what will happen here. This is what we summarize this video by saying X bar doesn't equal the true value of the population. We're always interested in the true value of the population and not the estimation itself, right? X bar is just a way. So the true value may fall around the X bar. This is a good information for us, right? So this X bar is important here. We always make decision for the population. We don't make decision for the sample. So very careful here. We just use the sample as a way to develop decisions for the population. That means we only use X bar not to make decisions. It's actually to build the new information for us to make decisions. So we need to build a confidence interval for the mean value for the population using this equation up here, as you know. For the true value, then we can calculate the confidence interval by applying the lower limit, which is X bar minus error margin, and upper limit by X bar plus error margin. The error margin equals the t-value, which is basically how many standard error. So to calculate the t-value, we need the alpha based on the confidence interval, and we need also the sample size to calculate the degree of freedom, and finally we calculate the standard error by this equation. And we can use the same concept to know where we are from the benchmark by taking the lower limit and upper limit for the benchmark using the same concept by taking the error margin. So I hope, yeah, of course you can, let me make the last one here. If you want to repeat the same thing for another variable, you can just replicate it. So all what you need to do is to copy this sheet. Let's make another sheet here for another variable if you want. Let us put it here. Now I want this for x6, for instance, one of the other variables. So I don't need always to do it for only the dependent variable. For that reason, I have to go ahead and get the x6 data, right? So I'm going to go ahead for my data set. And remember x6 control copy, it was product quality. So now I can go ahead here, and all what I need to do is to put here control paste them here, and then everything is going to change. Remember here, this is called product quality. So now product quality, this is the average of product quality. This is the count, it's the same. Now the standard deviation is here. The standard error is this value. So everything changed in this sheet. And now even the decision here, we are even better than the market. But there is very, very important point you need to pay attention to. It's still 7.2 is the benchmark for X19. Now I want the benchmark for X6. So I have to go here to variables. If you go here, you find here X6, the benchmark is 7.5. So I need to go back to the sheet for X6, change this to 7.5. Then I look at the output here. The output here, we are better than the market. See, everything change here. You can play with this sheet. Make sure always to change this value. I will make it really something like that to know that you need to be worried here. Always take care to enter the correct benchmark, right? Let me take this, put it in the second sheet. I didn't do it here. Put it there, change the color, and now you have everything again. I'm gonna save it, and thank you for listening. And yeah, go ahead to another sheet where I'm going to talk about the second topic.